audible?
Good
Good
morning,
morning,
ma'am.
ma'am.
Yes. Yes.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Madam, two
Morning.
minutes wait ಮಾಡ್ರಿ.
ಯಾರು
ಕೇಳಿ
ಹೇಳ್ತಿರೋದು?
ರಾಯಬಾಗ್. ಕೇಳಿ ರಾಯಬಾಗ್.
ಕೇಲಿ ರಾಯ್ಬಾಗ್.
Good morning, Miss.
Good morning. Very good morning. So you're settling now, Kaylee Raibag. Okay. Set Raibag, join Agi. I'll start. Yes, D and F block chemistry we were discussing. I will be finishing this chapter in hardly, I think next 1 or 2 class will be done with this chapter. So for next week, from Tuesday or from next Thursday, I'm going to start with new chapter. Now for that, I need to have an idea which chapter to take. You should, the chapter should be done at your college also. Rani Bennu, can you tell me, is alcohol phenol ether done for you, Rani Bennu students?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes. Saint Joseph, it is done, right?
Yes, it is going on.
Sorry, you're not audible. Can you?
Miss, we are done with alcohols now. Phenols, Mrs. Teaching.
They have started. Okay, fine, fine. Okay. So I think from by next week, phenol part will also be done. No, not a problem. A new PU college, Raibag. What about you? Alcohol,
Miss,
phenol,
start.
ether. Done?
Start. Start.
Okay, good,
No, Miss.
good.
Ethers.
Ether's not done. Alcohol, phenol part done. Okay, fine. Next, Nippani students
Ma'am, done completed.
Yes, ma'am. Completed.
completed. Good. And next, I guess, Chikkodi. Am I audible? Students, Chikkodi.
Yes, ma'am. Yes, ma'am.
What about this chapter, alcohol, phenol? Is it done? Yes or
Completed.
no?
Yes,
Yes, ma'am.
completed, ma'am.
Yes. Yes. Okay. Dharwad students, am I audible?
Yes, ma'am.
Yes, ma'am.
Can I know whether alcohol, phenol, ether chapter done for you or not from any student? Alcohol, phenol, ether.
Yes, ma'am. It's done,
Yes?
ma'am.
Yes. Okay. Thank you. Thank you. Fine. So previous class, I think I discussed about alloy property, interstitial compounds property, and common oxidation state. Which was the concept that we discussed in previous class? Can anybody tell me?
Catalytic property.
Catalytic property also we discussed? Okay. So how, I mean, what is the reason for transition metal to act as a catalyst? Can you tell me? We shall start with that only. We'll continue with that
Ability
part.
to ability to adopt the variable oxidation state.
Very good.
They,
Very good.
they
Forms
provide
larger
larger
surface
More
surface
area
surface area.
area.
for the reactants
Very
to bind.
good. Very good. So more surface area and ability to adapt
Hello.
multiple
Uh,
oxidation state.
Oxidation state.
Yes, very good. So this was about catalytic property. So now we have discussed color, magnetic moment, ionization energy, catalytic property, alloys, and formation of interstitial compounds. So today, before going straight to the question, I want to discuss about two important compounds which we study in this chapter. That is the D block compound. Can anybody tell me the important two D block compound? If the for the ones whom this chapter is completed, they should be knowing. Dichromate, chromium compound and manganese compound. So the structure, their property, it is very, very important. The question will be asked based on that. So there are two compounds of chromium which we are going to discuss. Chromate, that is CrO4 2 minus, and dichromate, which is Cr2O7 2 minus. Okay, I'll write the structure because they will ask the question based on structure only. So this is the structure of chromate. Chromate, CrO4 2 minus. and dichromate is this. Okay, this is dichromate. Can anybody tell me the oxidation state of chromium in dichromate and chromate?
+6.
6.
In +6 in? Here it is
Chromate.
+6.
Yes, ma'am.
Very good. What about oxidation state over here?
+6.
+6. Very good. So there is no difference in oxidation state of chromium in both chromate and dichromate. Remember, okay? Especially Chikkodi students, I guess this chapter was not done for you earlier. So everybody note down these. I mean, if you have notes with you, it is already taught and you have these things written on your notes, fine. If not, please write this because this is very, very important point. Yes, chromate and dichromate, the oxidation state is similar. Now, the color of chromate and dichromate. Color of dichromate is orange.
Orange.
Yes. Chromate is yellow.
Yellow.
Yes. And what can we say about their geometry? What is the geometry? The structure?
Tetrahedral.
Very good.
Tetrahedral.
Yes, geometry is tetrahedral. Tetrahedral. Short form I'll write TD. Okay, TD stands for tetrahedral. And here also tetrahedral is the geometry, but we have two tetrahedral form. One is
Linked.
this. Yes, this part. Another tetrahedral. We have two tetrahedral
audible?
form. Yes? Any question, any doubt? We have two tetrahedral form. And you tell me whether the chromium in both the case, chromate and dichromate, does the chromium have unpaired electron?
No.
Chromium is in
No.
no, right? +6 oxidation state. If it doesn't have unpaired electron, then it will be diamagnetic. Diamagnetic. Here also the chromium is diamagnetic. So with respect to oxidation state and magnetic property, there is no change. With respect to geometry, it has one tetrahedral unit, the chromate one. This has got two tetrahedral unit. And color is orange for dichromate, color is orange, so yellow for chromate. Okay, these points you have to remember about chromate and dichromate. This is two important compounds of chromium. Another two important compounds are of manganese. We'll see about manganese. I hope you have noted this, right? Be quick in noting because we have to solve MCQs also. Manganese, if I take KMNO4, which is potassium paramanganate. Yes, paramanganate. The difference in paramanganate and manganate is in manganate, this is manganate, okay? This paramanganate means K plus MnO4 minus. Can you tell me the oxidation state of manganese?
+7.
+7.
Plus
Very good. Here it is
+6.
+6. Very good.
+6.
+7 means, does it have unpaired electron?
Yes.
Yes.
Is it?
No,
+7?
ma'am.
+7, no. What is the, electronic configuration of manganese? D5S2, right? +7 means you have to remove all the 7 electron. That means you don't have any unpaired. No unpaired electron. That means it is diamagnetic in nature. Diamagnetic in nature. Here it is +6. That means one unpaired electron, it is paramagnetic. Paramagnetic. And color of paramanganate is purple or violet. ಏನಾದರೂ ಹೇಳಿ. So here the color is this color, green. Structurally, both are similar. Can you tell me the structure of this with geometry?
Tetrahedral.
Tetrahedral. Yes,
Tetrahedral.
yes. Tetrahedral. In both the case, the structure is tetrahedral. Okay? No difference in the structure. The difference is in the oxidation state, +7 +6, the magnetic property diapara, and the color, purple and green. Okay? So these differences you have to remember, the properties, the basic properties of this compounds you have to remember. Okay? Now, we'll not waste our time more on synopsis.
Excuse me, ma'am.
Yes?
Ma'am, does all the bond lengths between chromium and oxygen are same or different?
We'll discuss that when we get that question. Where is this question from?
Nippani, class 19.
Yes, we'll discuss when we get that question. I'll give you that question in some time.
Yeah.
Now, she had asked the same question. I have the same question. You think and tell me, then I will explain. In dichromate, they're asking, what about the bond length? Are they equivalent? All the chromium oxygen bond, are they equivalent or not? If they
No.
are equivalent, which are equivalent?
B.
Anybody?
Option B.
Anybody, the one with Q cards, I think St. Joseph and
B,
Nippani
B, B,
students.
B, B.
Option is
Answer using Q cards.
option B. Option B.
Option B, this is from which class?
New Few College class 1.
Okay.
Option B.
Option B from
Nippani.
Nippani. Okay.
Option C.
C.
Myself
All.
bathroom puri.
Option A, ma'am.
Option A.
Dharwad, from
Miss,
Dharwad.
option C from St. Joseph.
Option C from St. Joseph. Okay. So, from your poll result, majority is with option B. Now, those who are answering option B, I even heard most of you saying option B. Why is it option B? Can anybody explain, the ones who have answered option B? I'll take the same thing. The structure I had written, right? We'll take that. This is dichromate, right? Yes, why option B? Option B says 6 of the chromium oxygen bond is equivalent. How do you say that 6 of the chromium oxygen bond are equivalent? How? How can you say that? Yes? Which 6 bond do you think? Which 6 bond of chromium and oxygen are equivalent? Anybody? Are? Most of you went with option B, Alva, huh? Any reason? Why do you think so? So look, when I have this dichromate ion, we have this negative charge, right? And we have this pi bond. Pi bond. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ resonance ನಡೆಯಕ್ಕೆ start ಆಗತ್ತೆ like this. If I have to show you, I'll show this properly for better understanding. So this is okay, this is our dichromate anion. Now we'll in the negative charge we have. Okay, this negative charge will form a bond over here. As soon as this form bonds, this pi electron gets delocalized. That means I can write this structure, resonating structure. Again, this can come back and this can shift over this oxygen. That means I can again write one more resonating structure like this. So whatever that is happening with this part, the same thing will be happening over here. Now when you see resonance happening like this, how do how do you say what kind of bond is over here between chromium and oxygen? Now when you see this chromium and oxygen here in this part, you would observe it has a double bond, right? This chromium and oxygen. Now when you see the same chromium and oxygen in this resonating structure, you would observe a single bond. Do you say there is a single bond, or do you say there is a double bond? This I'm speaking about. This part I'm speaking about. Right? I've written this delocalization part. In the first structure, this chromium and this oxygen has got double bond. In the last structure, the same chromium and oxygen has got single bond. Now, what will you say about that bond? Is it a double bond or a single bond now?
Single bond.
Huh?
Single bond.
Single bond.
Single bond. How many of you think it is single bond? Yes? Tell me yes if it is a single
Partial
bond.
double bond.
Very good. Who is speaking? Who is telling this answer?
Chikkodi.
Chikkodi. Very good. We say, we don't say it is a single bond. We not even say it is a double bond. We'll say it has, this chromium and oxygen has partial double bond character. Partial double bond character. Whenever there is resonance, whenever there is delocalization of electron, you cannot be surely saying there is a double bond, not even a single bond. It is always partial. It is something that we don't know. Double idea, single idea anna gottilla. Eradu riti character. Both kind of character we are seeing. That's why we say partial double bond character is there. This is something that you have studied in your organic chemistry, like benzene. If you take benzene, we have 3 pi electrons, right? We say all these pi electrons are delocalizing. And then we say each carbon-carbon bond is partial double bond. Not a single bond, not a double bond. The same thing is happening over here. This 3 chromium-oxygen bond, this 3 chromium-oxygen bond, they are undergoing resonance. So due to resonance, all these chromium-oxygen bond, I'm having disturbance from somewhere with mic. Coordinator, kindly look at this. So this 3 and this 3, due to resonance, they have partial double bond character. That's 5. 6 chromium oxygen bonds are equivalent. Equivalent andre yenu? On what basis? They are saying they are equivalent in bond length. If you take the length of this chromium oxygen bond in all these cases, it will be same. That's why they are saying it is equivalent. Understood everybody? Yes or no?
Yes, ma'am.
Yes?
Ma'am.
Remember this resonance concept that is happening over here. I think if you see your NCRT, in your NCRT, when they have taken chromate and dichromate, they have not mentioned the double bond in this case. In manganese case, they have mentioned. Don't get confused, okay? You have the double bonds over here. Okay? Now, we'll discuss some questions based on the concept that we already studied. Yes. Can you answer this?
Option C.
Option C. That option C was from which class?
Option B, ma'am.
Nikani class 20.
Good. You're very
Option C,
quick.
ma'am.
Quick. You're very
Option
quick.
C.
Option C, ma'am.
When I say
Option
good,
C.
it doesn't mean that the answer is correct, okay?
C.
Option
Option
C.
B.
Option B. What are you actually finding out over here? You're finding out X. What is X actually? I mean, what does X represent?
Option D.
Oxidation state of
Yes,
iron.
yes, oxidation state of that iron. Yes, your poll result is also saying option C. So they are saying magnetic
Ma'am, excuse me.
moment is root 24, and we know the formula for magnetic moment, root of n into n plus 2. So when do we get root 24? We get when n value is 4. Am I correct? You will get
Yes, ma'am.
4
Yes, ma'am.
into 4 plus 2, 6. 6 4s are 24. What does n value represent? N value represent unpaired electron, right? So that means the Fe sum plus should have 4 unpaired electron. If you take X as 2, then you would get Fe2 plus, right? Iron is D6S2. Remove 2 electron, you end up having 6. Now take 1, 2, 3, 4, 5, 6. Totally we have 4 unpaired electrons. So if we put that 4 unpaired electron, then only we are able to get root 24. Very good, very good. So that was easy, and you had an idea about that. This is, I need very
Option
quick
B.
answer.
Option B.
Option B.
Option
Option B, ma'am.
Option B. Ma'am.
Option B,
Option
ma'am.
B. Option B,
B.
ma'am.
B, right? Yes, yes, very good. Option B is correct. Tetrahedral, correct. Okay. Next, yes.
Option C.
C.
Option
C.
C.
Option D, ma'am.
Option D, fourth one.
D.
Okay. Poll result, Joseph and Nipani. Cue card answer. So these are PYQs, okay? If you're seeing this year, these are PYQs. I'm discussing PYQs. This is 2020 PYQ.
Excuse me,
Option D.
D, fourth one.
Ma'am, are we audible?
Yes, which class?
Saint Joseph.
Yes, 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 you're audible, you're audible.
Option C, ma'am.
Option C, okay. Poll result,
Option D.
C and D. C and D, there is cutthroat competition between option C and D, and it is similar also. It is vice versa. Okay, I would like to ask, how is it option C? Those who are answering it as option C, why option C? Why Cu2Cl2 is more stable than CuCl2?
Cation has more charge.
Cation has more charge. Okay, that is the reason. Okay, any other reason for answering it as option C?
Miss Cu2 plus is more stable in aqueous media than Cu plus.
Than Cu plus in aqueous medium. Okay, fine. Others who are answering it as option D, what is your reason?
Cu plus d orbital fully filled.
Fully filled. That's why it is more stable than Cu2 plus, right? That's your reason. Okay, so why did I ask this question? Because I have explained the concept in the previous class, I remember. Those who are saying this option,
Hydration energy.
very good. I wanted that part. I wanted to hear that one. Hydration energy, hydration energy. I told you. You cannot be simply applying this everywhere and tell this is more stable than this. No, that is wrong. First of all, let us write this properly. Your reasons and all ಹೇಗಿದೆ ಅಂತ ಅಂದರೆ ನೋಡಿ, Cu2Cl2 we take, CuCl2 we shall take. How do you break this? 2Cu plus 2Cl minus. How do you break this? So Cu2 plus 2Cl minus. That means copper is in +2 oxidation state in Cu2 plus. Alva? Sorry. Copper is in +2 oxidation state in CuCl2, +1 oxidation state in Cu2Cl2. And in the previous session I had told you Cu2 plus is more stable than Cu plus due to high hydration energy. Due to high hydration energy. ಇಲ್ಲಿ ಹೇಳಿದ್ದೆ. More amount of water will get attracted towards Cu2 plus. So that's why it will stabilize Cu2 plus. That's what I told you, right? So in that case, this should be more stable than this. Where do we have that? We have that in option D. Yen madidira? Option C, whoever is answering option C, your reason is option D's reason. Option D answer ಮಾಡಿರೋರು, you are answering for option C. The reason you are taking is opposite. Okay? I hope you understand how to dissociate them into ions. Okay? Cu2 plus, this is more stable. Option D is correct. Option D is the correct answer. Okay? Don't forget this. This is very important. As you can see, I had spent literally 15 minutes to 20 minutes to explain this. Why? Because this is very important. Yes.
Excuse me, ma'am. Repeat once again, ma'am.
Which one? Where is this from?
Dharwad.
Dharwad. You know why Cu2 plus is more stable than Cu plus? In the previous class I had explained. Do you remember that?
Yes, ma'am.
Huh? More hydration energy. So that's what you have to find out. You are given 2 different copper chlorides. Okay? In one of the copper chloride, copper is in +2 oxidation state. In another copper chloride, copper is in +1 oxidation state. +1 oxidation state. Now, +2 is more stable than +1. That's what you have to find out. Find out the oxidation state. If you remember +2 is more than +1, then the only thing that you have to do in this question is find out the oxidation state of copper in both the salt. Yadru +2 ide, that is more stable. Aste. Understood?
Yes, ma'am.
Ha. Okay. Next. Can you answer this?
Ma'am, can you drag the question down, please?
Sorry?
Ma'am, we are not able to see the question.
You're not able to see the question? Okay.
Upper side of the question, ma'am.
Upper side of the question. I think it's got locked. Now it's not changing. It's not changing. Okay. I'm going to read your question. A transition metal exists in higher oxidation state. A transition metal exists in higher oxidation state. Then it will act as what? It will act as
Reducing agent.
what?
Option B.
Are you able to see option? Are you able to see options?
Yes, ma'am.
Yes. Okay. Huh.
Option B.
B, ma'am.
Option D.
Option
Reducing agent.
Option D.
reducing agent.
Yes.
B.
D.
Option D.
D. Fourth one. Okay.
Yes, ma'am. B.
Second and fourth you tell guys, please.
Fourth one.
Okay. Fourth one. Yes. Poll result. Did I get poll result? Saint Joseph. Have you answered using cue card? Saint Joseph Nipani. Yes. It's option A. You're going with option A. Some. Okay. Can anybody tell me how this works? You know, how do you say whether it is reducing, oxidizing when it is in higher oxidation state? Now, first of all, yes, you tell me, then I'll tell you. Whatever your thought process is, you tell me that. How do you know, how did you come up with that answer? Option A, option B, whatever your answer is. Anybody? New PU Raibag? Nippani, anybody? What is your thought process? You're just guessing or what? Huh?
Is the element which undergo oxidation, it act as a reducing agent.
That is correct. That is correct. That is correct. Very good. So here, look, if you take transition metal, that transition metal can be in any oxidation state, low oxidation state or high oxidation state. It can act as both chelating agent and coordinating and can form coordination compound. What are these? These are something that you don't know. So that's why you don't have to worry about C and D. Right? These two things you will learn in next chapter, coordination compound. So now, why did I give this question? I knew these two are something that you would already know. And the answer lies in A and B. Okay? Now, how would you analyze this? That is the question. They are saying the transition metal, a particular transition metal, let us take it as some M. It is in some higher oxidation state, for example, some okay. This is the highest possible oxidation state this transition metal can take, okay. Now, what this transition metal can do, whether it can oxidize other or it can reduce other. Nodi illi, now there is some kind of conversion ankoli. Let's say I have added some A, it has started reacting with A. Now, this is in +6 oxidation state. This is the highest oxidation state. This is the highest oxidation state andre it has lost maximum electrons already. Okay, already ಎಷ್ಟು electron it can lose, it has lost all those electrons. Now, the only thing this metal can do is gain electron. Now, whenever this metal is trying to react with anything else, it will try to gain electron. If a particular species is gaining electron, now what do you call that process? Species is gaining electron. It is getting oxidized or reduced?
Reduced.
Reduced.
Very good, very good, very good. If this is gaining electron, if this gains electron, this gets reduced. Okay, if this itself it is getting reduced, it will oxidize other. It will oxidize other. The one which oxidizes other, it will be called as what agent? Oxidizing agent or reducing agent?
Oxidizing agent.
Oxidizing agent.
Oxidizing
Oxidizing.
agent.
Okay, agent. This is acting as an agent to oxidize other. Okay, why it is acting as an oxidizing agent? Because this metal, it cannot undergo further oxidation. It cannot lose. Oxidation means what? Losing of electron. It cannot lose further electron. It has lost maximum number of electron possible. Now, all this metal can do is, it can gain electron. So that's why this is undergoing reduction, this is getting reduced. If it is getting reduced, it will oxidize other species. So that means it is acting as what? It is acting as oxidizing agent. Option A is correct. Understood everybody? Yes?
Yes, ma'am.
Yes, ma'am.
If the question was ulta, a transition metal exists in lower oxidation state, idre ಏನು ಆಗ್ಬೋದು answer?
Option B, reducing agent.
Reducing agent.
Reducing agent. Okay, the question can be reversed. Remember, if you understand this one, you'll be able to answer that also. Okay, good. Yes. So I don't have to explain anything. You see a reaction over here. You have to balance this reaction. They're asking you this coefficient, A and Y. What coefficient you would add to balance this? That is the question.
Option B, ma'am.
Option B.
Option B, ma'am.
This B.
Option B.
B. Yes. Q card
Yes,
answer
you
I'm
are-
waiting
you are-
for.
Option B, ma'am.
Look, this question. B. Okay. This question, you may term this question as a question from D block elements chapter, or it can also be a question from redox reaction. Okay. In first year you have studied redox alva. From there also this kind of question may arise. So that's why this is important, you know, the balancing part. Chances ide, ತೀರಾ ಇಲ್ಲ ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ. Yes, Q card result also you're going with option B. Okay, let us take option B then. According to option B, A is 8 MnO4 minus plus, let us later try to balance this, and H2O is just like that. We don't have any coefficient, that means only one H2O. They have not given any variable. MnO2. Look, if this is 8, even this x has to be 8, right? We have to balance. So this is also 8. And here SO4 2 minus. So this Y you have taken as 6. Let me take 6 plus OH minus. Okay. Now, if oh, if this is 6, then what should be here?
3.
Because
Three.
here we have 6.
3.
3, right. Okay, I'll take this as 3. Now let us see, all the atoms are balanced. Manganese is 8. Both the case it is balanced. Sulfur is 3 2s are 6. Here also 6. It is balanced. What about oxygen? Oxygen, let us count. Here 8 4s are 32. Yes. 3 3s are 9. Plus here there is 1.
42.
10 plus 32,
OH
42.
minus.
Huh. Yes, yes. Here it
16.
is 16 plus 6 4s are 24. And here, this is already what? 20, 30, 40. That means we need 2 more oxygen. So I will add 2. And hydrogen will also be balanced if I multiply this by 2, right? 2 hydrogen plus 2 oxygen, 42. Very good, very good. That was very quick. Yes, option B is correct. So this is another kind of question you can think of. Yes, let us take this question. Number of electrons transferred in each case when KMnO4 acts as an oxidizing agent to give these species.
Option A, ma'am. Option A.
Option A. Okay.
Option A, miss. Option A.
A. Okay. Nippani St. Joseph, your Q card answer. Yes, option A. Fine. How do we solve this for those who didn't understand this? They are converting KMnO4 to these species. Okay? MnO2, then Mn2 plus, then MnOH thrice, and last MnO4 2 minus. Okay, and their question is, in each transformation, how many electrons are transferred, or electrons movement? What is the number of electrons that are transferred? Okay, how do we find out that? Very simple. Those who are answering this, can you tell me what did you do to get this answer? Option A and the answer madidira, and I think you're correct. How did you answer this? Option A, how is option A correct? How do you know these many electrons have been transferred? Anybody? Nippani, Dharwad, Chikkodi. How do you do this? Arey Baba, you don't know how do you do this? Simply answering everybody. Okay, you tell me the oxidation state in each case. That you will do for sure. What is the oxidation state of manganese in this?
Plus
Plus
7.
7.
Seven.
Plus 7.
+7.
Plus
Correct.
7.
What is the oxidation state in
4.
this?
Plus 4.
Plus 4.
Plus 4.
+4. Correct. Here though +2 they have given.
Plus
What about
plus
this? OH
plus
is 3. OH carries -1. 3 OH minus means Mn will be having
plus
+3.
3.
Okay. This one
Plus 1, ma'am. Plus
Plus
1.
1.
Plus 6, ma'am. Plus
is it?
6.
Plus
Plus
Ah,
6.
+6. Just now we discussed alva paramanganate, manganate. This is +6. Now you have found out the oxidation state. Now oxidation state andre artha enu? If this is getting from if this is getting converted from +3 +7 to +4 andre, what does that mean? Earlier it had lost 7 electron. Now it has only 4. It has lost 4 electron. Okay, earlier -7 electron, now only -4 electron. ಎಷ್ಟು electron gain ಆಗಿದೆ +7 to +4 ಆಗಕ್ಕೆ? ಎಷ್ಟು electron gain ಆಗಿದೆ?
3.
3 electron? 3 electron gain ಆಗಿದೆ. Yes. ಇದು Mn+7 ಏನು ಮಾಡ್ತು? It gained 3 electron. So that's why it is converting into Mn+4. Just do the subtraction. 7 minus 2 ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಎಷ್ಟು electron involve ಆಗಿದೆ? 5 electron ಅಷ್ಟೇ. Yes.
4.
They are saying this
4
is
electron.
oxidizing agent.
4.
Next
4.
ಏನು? Yes.
4.
4 electron.
1
1
electron.
1 electron. Okay. So ಅಷ್ಟೇ ಎಲ್ಲಾಯ್ತು 3 5 4 1.
One.
Option A. Correct. Option A. Alva, this is oxidizing agent. Just now we discussed alva. This is oxidizing agent andre it will oxidize something else and itself it undergoes reduction. Itself it will take electron, it will convert into some other species. It will that's what is happening. It is converting into some other species having lower oxidation state. Okay. What you have to do whenever this kind of question is asked, find out the oxidation state in the reactant, find out the oxidation state in the product, just take the subtracted one. Okay. Yen barate, that will be your number of electron. Very simple this is. Okay. Okay, let us take this question. Understand this question properly. Okay. This is also a PYQ, as you can see, previous year question. Mn2 plus compounds are more stable than Fe2 plus compounds towards oxidation. Towards oxidation.
Option C.
Option C.
Option C.
C, ma'am.
Option A, ma'am.
See. What do you mean by, it's okay, you don't have, look, whenever the question is very simple, you don't have to use cue card. Whenever I say you to answer using cue card, then only you answer, okay? Yes, now you can answer this question orally. I want you to explain me what does this mean, this point. This point, what does this mean? What do you understand from this question? What are
Option
they
A.
asking? क्या है, क्या बात है? I'm asking you to explain me what does this question mean. You're answering directly. What does this mean? Mn2 plus compounds are more stable than Fe2 plus compounds towards oxidation to their Fe3, I mean +3 oxidation state. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಯಾರಿಗಾರ ಗೊತ್ತಾಗಿದೆಯಾ?
Yes, ma'am.
ನೋಡೋಣ ಖಾಲಿ. Mn2 plus Fe3 ಇದಲ್ವಾ? ಅಂದರೆ ಅರ್ಥ ಏನು ಅಂತಂದರೆ, look.
Greater stability.
Let's say,
Removing third electron from the.
You're not audible properly, I'll explain. Okay. So let us take two scenarios wherein both iron and Mn in +2 oxidation state is getting oxidized to +3 oxidation state. Now if you take iron in +2 oxidation state, the configuration is D6 and Mn in +2 oxidation state is D5. Alva, you tell me which has less tendency to get oxidized?
Manganese. Iron, man.
Huh?
Iron.
Manganese, right? Manganese. Why? Because this is already stable in D5. That's why it doesn't want to get converted into D4, which is less stable. This is, you know, right? D5 half filled, more stability. Already stable irado, oxidize agi. Why does it want to become less stable? That's why this has less tendency to get oxidized. To get oxidized. ಇದನ್ನೇ ಅವರು ಅಲ್ಲಿ ಕೇಳ್ತಾ ಇರೋದು. This is what they are asking. Mn2 plus compounds are more stable towards oxidation to their +3. Are more stable ಅಂದರೆ ಇದರಲ್ಲೇ ಸ್ಟೇಬಲ್ ಇದ್ದಾರೆ, ಇಲ್ಲಿ ಆಕ್ಸಿಡೈಸ್ ಆಗೋಕ್ಕೆ ಅವರಿಗೆ ಇಷ್ಟ ಇಲ್ಲ. ದಟ್ಸ್ ವಾಟ್ ದೇ ಆರ್ ಟ್ರೈಂಗ್ ಟು ಸೇ. ಓಕೆ, ಇಫ್ ಯು ಕಂಪೇರ್ Fe2+, this has more tendency to get oxidized. Why? Earlier it was D6. After oxidation it is getting converted into what? D5. That's what it wants, alva. Illikinta illi it is more stable in Fe3+. So this has more tendency, this has less tendency. That's why this is already stable. It is more stable at this state. It doesn't want to get converted into this. So your answer was what?
C.
Option C. Option A.
D onto agalla.
Option A.
C. Option C.
Option C, if you take, look, option C, if you take, Mn2+ has completely filled.
Option A, ma'am.
Does it
Option
not
A.
count?
Half filled.
Ah, it has half
Option A,
filled.
ma'am.
This is
Option
also
A.
not, this is also
Option
not,
A.
yes.
Option A.
Mn2+ is more stable with
Option A,
high,
ma'am.
yes, very good. High third ionization energy. We have studied about ionization energy. I'm not going to repeat it again. Option A is correct. High third ionization energy, very difficult to remove this electron. Okay, difficult to remove and convert to this. Option A is correct. Okay. Okay. Yes. Anybody? This is easy. This is easy. I just want to explain one concept. That's why I have taken this question. You would answer this easily.
Option C.
Wrong, they are saying. Wrong, which is wrong.
Option C.
Option C.
Option C, ma'am.
Option C.
See,
Option
see,
C.
correct.
Ma'am,
Good.
yes.
Just now we
D, ma'am.
discussed. Yes,
Option
very
C.
good. Yes. Option C is the wrong statement. Just now we discussed. It is directly ulta of this. The correct is Mn2+ is more stable towards oxidation. It doesn't want to get oxidized. So here they have given the ulta statement. Fe2+ is more stable. So that's why this is wrong statement. I understand, you know this. Now that other 3 points are something which I wanted to discuss. First one, Ti4+ and silver +1. They are repelled by magnetic field. Andre ಏನು? That means repelled by magnetic field. If the question is something like that, repelled means you have to apply or you have to think it is diamagnetic. Okay? Repelled means it is diamagnetic. If it is attracted by magnetic means it is paramagnetic. Yes. Why are they diamagnetic? Ag+, it comes under copper, right? It is like copper. Like copper, silver, gold, you know, right? They come in a single column, right? If you take copper plus is D10. The same is applicable for Ag+. That's why D10 is completely filled. It doesn't have any unpaired electron. It is diamagnetic. And Ti4+, you already know. Titanium, what is titanium? D2S2. Remove all the 4 electrons. You don't have any unpaired electron. Again, it is diamagnetic. So that's why option A is correct. Option B, Mn2 plus shows maximum magnetic character among the first transition series. Correct?
Yes.
Right? More number of unpaired electron, correct. What about D? D also, just now we discussed chromate and dichromate. Chromate ion has tetrahedral, dichromate ion has 2 tetrahedral. We saw, right? 2 tetrahedral units with the bond angle 126. Yes, this also you remember. I think I did not mention that. Where was this? This bond angle, it is 126, okay? This point also you remember, the bond angle in dichromate, 126. So that is also correct statement. Next. Yes, this question I wanted to discuss. How many electrons are involved in the oxidation of KMnO4 in basic medium? Okay, actually KMnO4 is not getting oxidized, KMnO4 is getting reduced, but the reaction, the redox reaction of KMnO4, if you see, in basic, in acidic and in neutral medium, number of electrons exchanged will be different. Okay, that I'll tell you now. If you know, you can answer, or else I'll tell you. Okay. So this is the conversion of KMnO4 in different medium, okay? Acidic, basic and neutral. Please note down this. This question is asked in several competitive examination, very important question. So that's why I'm telling you. I told you, right, this chapter is more of fact based. So they will try to test your memory. That's why this kind of question is important. This is the converted species. Permanganate is converting into these species. Now, how many electrons are utilized in this? How do you find out? Again, use the oxidation state wala thing. Everywhere we have manganese in +7 in permanganate. Here it is +2.
D, ma'am.
+7 to +2. Yeah, okay, +7 to +2. What is the number of electron?
5.
5. This is +7 to permanganate is +6. Number of electron is 1.
1.
Okay. Yes. This is +7 to +4. Number of electron is 3. Okay. In neutral it is 3. In basic it is +1 or 1 electron. In acidic it is 5 electron. So in this question they are asking in what medium? Basic.
Option
Basic is
Option A.
option A. Option A. Okay, fine. So we shall wind up today's session over here. In next class, I want you to bring your notes. For those people, this D block LMS chapter has been completed. Bring your notes. And for those this is not completed, bring NCERT textbook. Okay. Next class, it will be based on reaction. So that's why you need to go through the textbook or notes to answer that. So bring that. Okay. Thank you, students.
Thank you, ma'am.
Thank you, ma'am.
Ma'am.
Yes.
Thank you, ma'am.
Yes.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Bye, bye, bye.